Hello, everyone. We are here with Professor Andreas Smeonidis, who is the founder of Cyclops. And today we're going to talk about vibe coding. So, vibe coding is a trend nowadays. What does it actually mean?
Okay. First of all, thanks for the invitation. It's been an honor. It's great to discuss with you issues related to vibe coding and Cyclops. Practically, vibe coding is the new trend in software development. So, and not only software development, but also software engineering. So, practically, if we go a few years back, you would practically follow a process where you would have an engineer, usually a requirements engineer, defining what exactly the system should do. This is what we call software requirements. And then you should, or you would have an architect that would define the architecture of the system. And at the end of the day, developers would start developing based on the architecture that the architect defined and the requirements that the system should satisfy. Now we've moved to a completely different way of working. So practically, instead of going through that, let's say, structured process of defining software requirements, architecture, and then developing the system and then started testing and finally deploying software, what we now do is we trust LLMs to do that. So as Andrei Karpathy said, practically vibe coding, and he's the father of the term, vibe coding is the new way of developing software where you practically request from an LLM to build a software system like the one that you have in mind. So you don't follow a structured approach of defining requirements, of saying exactly what the system should do, but you just give the context. And based on this context, the model, the LLM model, can infer what exactly you're trying to build, and then it writes the code for you, selecting the architecture that the LLM feels that is the most appropriate one. So at that point, what you have is that you describe what you would like to build, let's say a system like Uber or a system like Facebook or Instagram or whatever, the range and the the scale of the system. And then the model gives you a solution that is practically a very well-written part of code following a very well-defined software architecture. And then what you have to do is you have to fix things. So you say, okay, I like this one, but I would like that. And you go in this iterative process where the model improves things. And at the end of the day, it gives you a system that most of the times work.
Okay, so practically you are the master of the whole application nowadays.
Exactly. So what you have now is you give the basic instructions and then you get the code back, the system back. And as I already said, most of the times this system is functional, not fully functional, but functional to a very good extent. And in fact, then you have to check what exactly you have received, right? Because you very well know that in most of the cases, LLMs are very good at producing a result that seems to be correct. And in the case of software development, they do have to follow a grammar, and this grammar is very, very strict. And then you have a system that it follows a syntactical way of building software, and this is also very easy for an LLM to focus on. But in many cases, they hallucinate because they don't understand what exactly you needed, and they generate something that seems good, but in some cases, it's not the one that you needed. So the maestro has to take that information back and be sure that what he requested from the system, what the system understood, is the one and the same. This is the one thing. And then be clear and understand if the architecture is good, the one that he or she needed, and at the end of the day, if the system is functional the way that the maestro wanted it and not what the LLM produced.
Okay, so it is a new shift in technology and the way software engineering works nowadays. But we do have to be careful about what the LLM actually produces and the actual the picture of the final product. We need to be more sure about what we want to do and not so much on how we want to do it.
Exactly. So practically nowadays software development becomes trivial. It doesn't really mean a thing. And to be honest, if you're in the field of software engineering, everybody knows that practically software development is the least interesting part of the whole process. So it is much more important to define a proper architecture on the system, understand what exactly your client wants and needs, and then deliver that and test that and be sure that this can work properly under operational constraints. This was the case always, right? So now what do you have? I mean, like, if you just take the software development part out of the equation, which is obviously very easy to do, and LLMs can do it super fast. This is what we say practically. Software development now can be performed in a couple of days with the agents working 24/7, while a person would feel tired, would decide to stop and feel a bit when they are overwhelmed. So what is important now is to be sure that practically the non-functional requirements of your system, like for example the scale that the system should work, the way that the system should be built in the context of usability or of performance, the security side of the system, are the ones that you should be focused on. This was always the case, but this usually, given the fact that you had expert software engineers dealing with the architecture, they would take all that information in mind in order to build the architecture. So you should have a system that would be performant by design or secure by design, because these were the main non-functional requirements. Now, given the fact that you don't need to have that expertise to build a software system, these types of information are usually left out or not given the proper attention or the proper focus that they should. So now you have code that is very good, it's functional. The code per se is well written, obviously. It follows standards like readability and blah, blah, blah. But in some cases, you may use a library that now has a known vulnerability. And this is one of the big problems, right? So if you go back and think about how code is being inferred through the LLMs use huge databases of code like open repos in GitHub or wherever else. And they know how to write good code, but this code is 6 months old, probably. So this means that you have dependencies there that are problematic nowadays. And this is something that you have to treat. This is one of the typical problems that you usually have. So you have a system that works, a prototype that works to be exact, but if you want to take that into a functional, fully operational system, you have to focus on those non-functional requirements and aspects of your system which are critical for everyday use and everyday operation. And this is the problem when it appears.
Yeah, so actually, what we're talking about is that prototyping is actually very easy nowadays due to vibe coding.
Super easy.
So the main question is, LLMs and the whole vibe coding system is easily to use. Can a person with no developing background use those tools nowadays to build an app the way they thought about it?
Absolutely, yes. This is a case that I usually discuss with my students. I tell them that my son, who is 10 years old, with the help of me, he built a small web game within less than 3 hours. But what do you get? You can describe it somehow, you get the code, but you don't have the ability to audit the code. So This is why I said that those non-functional aspects become the most important aspects in the software development, the software engineering pipeline, because the application that he built, he didn't know what framework to use, so he just selected what the LLM said. The system that it will run on, he didn't know, so he just followed the proposal, and this system was not secure, and it could not be used at massive scale. And this is how you differentiate from a prototype to a product, right? And this is what we're saying. So vibe coding is super cool. It's great. For me, I also use it in order to, test an idea, see things. When you take that into a product, then it starts being more complex. And also, you have to keep in mind that when you're talking about a product, you're talking about multiple iterations of software development with new features being introduced, things being changed, and this creates a chaos with respect to the maintainability aspect of the software. So think about having a system that has been iterated 3, 4, 10, 20 times from an LLM, always asking to practically add a new feature. So what the LLM does, in order to reduce the number of tokens, of words, or whatever, what they usually do is they focus only on that point, right? And you don't focus on the other side. So whatever you change here, it also affects that part of your system. And another thing is that when you improve performance, you make the system less user-friendly, right? Or whenever you improve security, you make things a bit more complex with respect to readability. And this is a typical win-gain case in software engineering. So you fix something, you break something else, or you mess up with something else. These are things that a non-expert cannot really know and fix. And another thing that I consider important is the fact that you need accountability. If you take this prototype and you say that it's fine and you don't audit it properly and you don't test it, you don't check it, and you take it to production and something breaks, is it my fault or the LLM's fault? Who was the one that should be accountable for that, right? Yeah. And this is when all the legal implication also appears.
Yeah. Okay. So a small summary. Vibe coding is extremely cool nowadays, and I think
and efficient. And efficient, right? It's not only cool. It's not about, when it started about vibe coding, it was cool to be, a guy using these new tools. But now everybody says that is mainstream on the way that software development and not engineering is being performed. So super cool.
Yeah, and I guess it helps young developers to acquire some skills much faster than before. But we need to be extremely careful.
Well, what happens is that you can easily generate code like a pro, but you don't master the art of software engineering. So you need other tools, other methods, other processes to be sure that what you develop is good to be software that you can deliver. So development and delivery are two different things. So super cool, not for only for youngsters, but also for old guys like us, to test concepts, to see things happening, to generate prototypes, to discuss in a market validation concept or context things. But you always need to be sure that you understand the code and you can deliver a good code. So one could say that in order for a young developer, a junior developer, to learn code using LLMs, super cool. In order to take that junior developer and write one feature for a product, super cool. But you cannot, build a new product only based when you start from this vibe coding approach.
Awesome. Thank you so much, Mr.
Thank you
Simeonidis.
very much. It was great being here.
Thank you.